Okay, so this is a power series PQ question 6. Okay, we are given that fx is equals to e to the power of cos x. We need to find f at x equals to 0, f prime 0, and f double prime 0. And hence we write down the first two non-zero terms of the Maclaurin series for fx and give the coefficients in terms of e. Right, so let's start doing this. So we know that fx is equals to e to the power of cos x. Alright, and finding f0 is easy. All we need to do is just start x equals to 0. Okay, then you have e to the power of cosine 0. What's cosine 0? Cosine 0 is just 1. Okay, so this is just e to the power of 1. We can just write it as e. Okay, what is f prime x? F prime x, remember, if we were to differentiate, the formula is that when we differentiate e to the power of fx, this will give us f prime x e to the power of fx. Okay, then next, okay, so after that we differentiate our cos. It will give us negative sine e to the power of cos x. Okay, because this is the f prime, right? Okay, then what's f prime 0? Now very quickly you can see that f prime 0 actually will just give you 0 because this is just negative sine 0 multiplied by e to the power of cosine 0, and next sine 0 will just give you 0, so it's just equals to f prime 0 will just be 0. F double prime, how to find f double prime? The f double prime here, we have we need to differentiate this one more time. Okay, we need to differentiate f prime one more time, so we probably have to use product rule. Okay, so we differentiate sine x, that will give us minus cosine x. We keep e, okay, and then now we keep our sine x, and we differentiate e to the power of cos x. Now if we differentiate e to the power of cos x, we are just going to get minus sine again, and e to the power of cosine x one more time. Alright, and so simplifying this will give us negative cos x e to the power of cos x plus sine x, so you have minus minus become plus, sine x will give you a sine square. This will be e to the power of cos x. Okay, and with that you're almost done. Okay, so what's the last step is to actually substitute f double prime 0. Okay, f double prime 0, okay, so this is going to give me okay, so this is going to give me 0. Since sine 0 will just be 0, this will give me 0. This will give me a negative cosine 0, which is negative 1. E to the power of cosine 0 will just be e to the power of 1. Okay, so the answer will just be negative e. Okay, with that you have your, let me just use green to show you what the important portion. f0, you have f prime 0, you have f double prime 0. Okay, so have we answered the question? Yes, we have. Okay, hence write down the first two non-zero terms of the Maclaurin series. So Maclaurin series, okay, you just need to go back to your MF26. You know that Maclaurin series fx, this is equals to f0 plus f prime 0x1, first derivative power 1, second derivative divide 2 factorial power 2. Right, and is that all? Okay, we just write the first two non-zero terms, right? So the first one, and you know that this is 0, so we probably need to end up writing this and this. Okay, so we go on, and we have f0 is just equals to e. Okay, this is from part 1. Sorry, part 1. And f prime 0 is just equals to 0x, and f double prime 0 we know that is equals to negative e. So this is a negative e over 2 square. So with that, just simplify your answer and we are almost done. So this is the first two non-zero terms of the Maclaurin expansion for e to the power of cosine x. Okay, so what is next? Okay, so now we need to compare. We say that the first two non-zero terms of the Maclaurin series of fx is equals to the first two non-zero terms of the expansion 1 over a plus bx squared. Okay, so does it mean that we have to also do Maclaurin for this? No, because we know that, remember I told you that the power series expansion and Maclaurin is the same. The answer will be the same. So given of that, we can take 1 over a, this is 1 over a plus bx squared. Okay, and we can write it again. So you see that we are always writing the denominator as a numerator, but to a negative power. Okay, and do I start? Haven't yet, because we know this is a. Before we start a power series expansion, we always try to change our constant to be 1. So we can factorize out a, and we have 1 plus bx over a. Okay, next. What do we do? Okay, so this is just equals to 1 over a, 1 plus, okay, so this is n, this is x, so it's n bx over a to the power of 1, 2 terms, 2 factorial power 2. Okay, and we'll stop here. After that, what's next? This is 1 over a, so minus b, 1 over a bx also, so bx over a square. Okay, plus so on, because we just want up to the term in x square. Okay, so we just want to find out to the term in x square, because we're looking at the comparison of the first two non-zero terms. So that means, right, we don't need to go up to x cubed. Okay, we don't need to go up to x cubed. After that, we're comparing the first two non-zero terms. So I know that these are the first two non-zero terms, and in my other side, these are the first two non-zero terms. So what does it mean? It means that your e, okay, so you compare, you remember just now we have our 1 over a, so it means that 1 over a is equals to e, and negative b over a square is equals to negative e over 2. Alright, so just comparing this, you just get a, from here you just get a equals to 1 over e, and your b, plus by Simon's equation, you get 1 over 2e. So that's all for question PQ question 6.